Final section in the chapter is dealing with simplifying radical expressions. So two radicands are like radicals if they have the same root and same radicand. So think about when we combine like terms traditionally, they have the same variable and same exponent, we're good to go. Same thing goes here, you want to have the same type of radicals, whether it's a square root, a cube root, fourth root, and the same number underneath. You can treat it like it is a variable. And then to put things into simplest form, you want to apply all properties. So that's thinking about, can I break down the number that's inside the radical? Can I simplify, combine like terms in any way? So that's what we're going to be focusing on in this section. So here, I talked about you want the same root. So I have the fifth root here, and then you have the same number underneath. So I want to think about, what is 7 minus 2? Okay, and that is equal to 5. So this would give me a 5 on the outside, and we copy down the root and then the number underneath. So we have 7 fifth root of 6 and 2 fifth root of 6. That gives me a total of 5. So that's that first type of example that we could see. The next example I see is dealing with, just put it down here for a second, is dealing with multiplying radicands. So I see that we have the same number underneath. So what I can do is I'm going to rewrite that radicand once. So I have the third root, and I'm going to think about 4 times 16 underneath there. When I multiply those together, I do get 64. So the first thing I always want to try to do is see, could I go through, simplify this, and get a whole number? So with this, I'm going to pull up our calculator. I might actually just minimize this and grab it up here. So it's a good step to always see, does this simplify to a whole number first? If not, we're going to be looking to break down the number that is inside that root. So I'm going to start with the cubed root. So I'm going to type the math button. And you can select that fourth option down, which is the cubed root. And I'm going to type in 64, see if it is a perfect cube, and it is. So get rid of that, and this is equal to 4. And that's my final solution, as much as I can do there. All right, so here is the main event. So simplifying radical expressions that also have variables in them. So I like to think about this in 2 separate parts. The first part is I want to look at that number separately. So I'm going to take the fourth root of 16 and kind of just think about that on its own. So I want to break that down. Let's see if I can take the fourth root of 16. So taking the root here is slightly different than what we've done before. I'm going to type in the number 4, and I'm going to hit the math button, and I'm selecting the 5th option down. The 5th option down is having me tell the calculator what root I want to take. Now notice for me that 4 turned a little bit smaller, and I'm typing in 16. So I get a 2. So I'm going to make this 2. And that simplifies so it fully comes out of the radical. Now, the last part we have here is the fourth root and of everything that has a variable. Okay, so y to the 12th and z to the 4th. Now, we mentioned before that when you take this root, okay, the fourth root is the same thing as taking something to the 1/4 power. So I want to see essentially, like I'm taking that exponent and I'm multiplying it by the exponent that I have under here. The way I like to think about it is I'm going to be taking each exponent and dividing it by the root. So you have x to the 8 over 4, y to the 12 over 4, and z to the 4 over 4. And then I'm just going to simplify those down. So this would be 2, x to the 8 divided by 4 is 2. Y, that's 12 divided by 4 is 3. And z, 4 divided by 4 is 1. And that would be my final answer there. So I always like to divide whatever root is by the exponent that's on the inside. And we'll talk about what happens if we get any type of remainder as we move forward. But that's what you're doing, and this would be my final answer. Let's take a look now at this last one here. So we're going to be looking at the 5th root. And I'm going to once again break this up and focus on the number out front. And then I'm going to also focus on the variables, so x to the 10th, y to the 15th, and z to the 5th. So the 5th root of 243, let's try that out. I'm going to pull up my calculator. I'm going to type in the number 5. I'll hit the math button, and once again selecting that 5th option down, and I will type in 243, and I get 3. I'll go back here. This part simplifies to 3. All right, now I'm going to be looking at my variables. So I'm taking the exponent that is underneath and dividing it by what root I'm looking at. So that's 5. 15 divided by 5, and z, 5 divided by 5. So this would be 3, x to the 10 divided by 5 is 2, y to the 3rd, and z to the 1st. Okay. All right, now I am going to move on to that back page. So sometimes you have powers that are not perfect. So I still want to go through and break this down. I still like to have the number be its own thing and focusing on my variables. So a to the 5th, b to the 9th, and c to the 13th. So the 5th root of 32, we'll start there. I'll pull up my calculator. 5, I'll hit the math button. I'm going to scroll down to that 5th option again. And I'm going to type in 32. And I do get 2. So that one does simplify to a nice whole number. Okay, now here's the next part where it gets a little tricky. I want you to think back to elementary school when you were learning about long division, just division in general. Okay, I'm going to focus first on my variable of b. Now I did mention before that we're taking the exponent that is on the inside and I'm dividing it by the root. Now 5 divided by 5, that will give us a nice whole number, but 9 divided by 5 will not. So let's think about this here. I'm going to take 9 divided by 5. 5 goes into 9 once, and I have a remainder of 4. So how this is going to work is, this is referring to the exponents that you will have. Now, the 1, that is what comes out. The remainder is what stays in. So what am I talking about here? So first off, let's think about this a to the 5th. 5 divided by 5. We'll have a to the 1st that comes out. Now, the b, I did say, this exponent that you have here, 5 goes in fully once. So I will have b to the 1st on the outside. We still have a 5th root here. We had a remainder of 4, so that means I still have b to the 4th on the inside. So your remainder is always what remains inside the root as your exponent. Let's try this last one here. So c to the 13th. So I'm going to take 13 and I'm dividing it by my root, which is 5. So 5 goes in fully twice. That means my exponent on the outside will be 2. 5 times 2 is 10. I'll subtract those. And my remainder now is 3. So that means I have a c to the 3rd still on the inside. So the number that comes out fully, that exponent comes out. The number that is remaining, that remainder, that stays on the inside. It'll be the same thing up here. When we're looking at my exponents for the b, the 1 came out, but we still had a remainder of 4, so that 4 exponent stayed inside. And this would then be my final answer. So 2, a to the 1st, b to the 1st, c to the 2nd, times the 5th root of b to the 4th, c to the 3rd. A little funky. With more practice, I think you'll be feeling a little bit more confident. Right. So some practice. Feel free to pause, give it a shot. The answer key is on Schoology, so you can take a look there. But I am going to work through these, so feel free to pause as you need. So I'm going to, like I said before, I'm going to break this up. Focus on just my number first. So the cubed root of 8, we'll pull that up. Math button. Looking at the 4th option down, I'll type in 8, and we do get a 2. So I know that at least on the outside, there will be a 2. Now I am going to then look at breaking down the cubed root of w to the 6th, x to the 3rd, y to the 12th. So typically what I do like to do, and you are welcome to do this or not, I always like to have my cubed root set up just as a place to put my remainder if I do end up having any. So we have 6 divided by 3 goes in twice. So I see that I will have w to the 2nd outside, no remainder. So I will not have any w's left over on the inside. Let's do the same thing now with my x's. So I'll look at my exponent for my x. It's 3 divided by 3 goes in once. So I know I have x to the 1st on the outside. Oh, once again, no remainder. So I will not have any x's remaining on the inside. I'll do one last time. We're going to look at the y's. So my exponent for my y is 12. I'll divide by 3. That's my root. So it goes in 4 times. So I know I have y to the 4th still on the outside. 4 times 3 is 12. So once again, no remainder. So I can actually go through and just get rid of that root altogether. And then here is your final answer. So that's nice when there's no remainders there. Okay. All right. Here for number 2, we have a square root. Now a square root, your exponent is always 2. So I am going to go through, split this up. So we have the square root of 25, and then the square root. You can put the 2 there or not. It's really your choice. Of r to the 2nd, s to the 11th, and t to the 7th. So my square root of 25, that does simplify to 5. Now, like I said before, I'm going to put this over here just in case I do have any remainders. That will be there. So let's break this down now. I'm going to focus on my r's. So my exponent that I'm starting with is 2. The root, a square root, is 2. So 2 goes into 2 once. So I do have r to the 1st, or just r, on the outside. Okay, that simplifies to 0. So just like the original problem, no remainders. So I will not have an r on the inside. Now I'm going to focus on the s's. So the exponent for the s is 11. Divide that by 2. So 2 goes into 11 evenly 5 times. So I have s to the 5th on the outside. 5 times 2 is 10. I do have a remainder of 1. So that means I will have s to the 1st still on the inside. Okay, and my last one here, I'll do this in green. We're looking at t. So my exponent for the t is 7. I'm dividing by 2. 2 goes into 7 evenly 3 times. So I will have t to the 3rd on the outside. 3 times 2 is 6. I do have a remainder of 1. So I will have t to the 1st still remaining on the inside. And that is, once again, my final answer. Now, anytime you have an exponent of 1, you can put the 1 there, or you can just write it without the exponent, your choice. All right, let's move on. This is our last example. Let's try it out. So I'm going to go through 4th root of 81. We'll start there. So once again, I'm going to type in 4, telling the calculator what root I want. I'm going to click on the option for number 5. I'll type in 81, and I get an answer of 3. So this simplifies to 3. And then you have the 4th root of d to the 3rd, e to the 4th, and f to the 9th. So once again, I'm going to continue to write this out. I'm going to write my 4th root. I'll leave that radical space there. And let's start with my first variable, so the letter d. I have my exponent of 3, dividing it by 4. Can 4 go into 3 in any way evenly? No. So that means my variable d will not come out. I don't have enough pieces to take it out. So it will still remain d to the 3rd underneath your radical. Let's move on to the next one. I have my power of 4. And I'm looking at the 4th root. 4 divided by 4 is 1. So I will have e to the 1st on the outside. 1 times 4 is 4. Subtracting, I get a remainder of 0. So I will not have any e left over on the inside. Lastly, we'll look at 9. So I have f to the 9th divided by 4. 4 goes into 9 evenly twice. So I will have f to the second power on the outside. 2 times 4 is 8. I will subtract and get a remainder of 1. So that means I will have f to the first on the inside. And that is my final answer.